Welcome everyone to this lecture on the Pandas series object. A series is a data structure in Pandas that holds an array of information or data along with a named index. The named index is really the aspect of a Pandas series that differentiates this from a simple NumPy array that we learned about in the previous section. As a formal definition of what a Pandas series is, it's a one-dimensional ND array with axes labels. So let's actually show you realistically what that means. So we already know that a NumPy array has a numeric index, which means if I have a NumPy array storing, for example, the years of independence of countries in the data, then I have a numeric index that's associated with that. So if I wanted to grab, for example, the year 1776, then I say, go ahead and index item 0 off this NumPy array. Now, that's all well and good, but the problem is that it'd actually be a lot more useful as far as the data is concerned to have it associated with a string label. Because right now I have to actually memorize the positions of the years instead of memorizing or knowing the association I want with them. And so what a Pandas series allows us to do is supplement that index with a labeled index. So the Pandas series essentially adds on a labeled index that can be strings or names or really anything you want here. And you'll notice now I'll be able to grab information off this Pandas series based off the labeled index, which makes it a lot easier to grab data in an informative way. So I can say, go ahead and grab the series at index USA, and it will return back 1776. That's a lot easier to use than having to memorize those index positions. And it's more in line with what real-world data looks like. Something I want to clarify, however, is that the data is still numerically organized. And essentially, you can think of a Pandas series as just holding a NumPy array internally and then adding on that named index. So I can actually grab information through a numeric index call or this labeled index call within a Pandas series. So essentially now I get the best of both worlds. And it's still very computationally efficient to store data in this format. So you'll have both access to a numeric index and, more importantly, this supplemented labeled index. So what we're going to do is we're going to explore the various ways to create this Pandas series object. And we'll also learn about some key properties and operations. And later on, we're going to learn how to combine series together with a shared index to create a tabular data structure called a data frame. So let's head over to the Jupyter Notebook and explore a Pandas series. Okay, here I am at a new Jupyter Notebook. First thing I want to do is import NumPy as NP in case I want to create some data. And I'm also going to import Pandas as PD. And import Pandas as PD is the main convention used for importing Pandas objects. And what we're going to be working with is the Pandas series object. And you can check out the documentation online for more information about a Pandas series. Or what's really useful is if you just call help on pd.series, note it's a capital S there, and hit Shift Enter, it's actually going to display the documentation here for you. And you'll notice it's very comprehensive. So it shows you all the methods available on a series. And if you keep scrolling down, it'll eventually actually show you examples. So here we can see examples of creating a series, how it deals with missing data, and so on. So there's a ton of information here. Granted, if you're this far down in this help function, I would just say go to the online documentation instead. It's going to be a little easier to read there. But it's always available for you here within an IDE by just calling Python's help on the Pandas series object. Let me go ahead and comment this out and continue. So if we say pd.series after importing Pandas as PD and do Shift Enter here, we have the documentation string or the signature here for the main ideas of what we need to pass in to a Pandas series. Lots of things like data, index, data type, name, and so on. But the main things we have to be concerned with here is data and then index. And that's really what's going to add on the supplemental index to the data, which is stored as a NumPy array within the series. So in fact, let's create real quick 2 objects. We'll create them as Python lists, just normal Python lists. We're going to create an index, USA, Canada, and let's say Mexico. So it's in line with what we're showing in the slides. And then we'll say my data is equal to, let's say, their years of independence, 1776, 1867, and then 1821. And so what I'm going to do is create a series object by saying my SER, my series, is equal to PD dot series, and we're going to say the data is equal to data, or my data actually. So we're passing in right now just data as a normal Python list. And if we run this and essentially ask for what does my series look like, you'll notice that Pandas immediately reports back your data organized internally. And internally, it's essentially converting this Python list to a NumPy array held inside as a Pandas series. So if you check the type of this object, it's going to report back that it's a Pandas series now. So it says pandas.core series. And you'll notice that automatically it's going to show you the default numeric index. But as we just explored within Pandas series, it also takes in this index parameter. So now let's not just provide data, but let's also provide index. So we'll say index is equal to, and now I'm going to pass in these string codes here, because it's going to be a lot easier to look up information based off the string that I know, such as USA, instead of having to memorize, oh, position 0 for 1776. So we'll say index is equal to my index, run that again to redefine the series object, and now we can see that the index is this labeled string index, which means I can actually grab information off of this almost as if it was a dictionary. So we'll say my series, and then I can say at 0, and it'll return 1776, or I can say my series at USA, and it also returns 1776. So you'll notice that the series object now retains both this numeric index by location and this labeled index, which is what we're going to be using throughout the course. Typically, we're going to have a labeled index, which is going to be easier to read than just searching through strings numerically. One more thing I want to point out is I'm being explicit here as far as what the arguments represent, such as data equals and index equal. Obviously, as long as I provide them in the correct order, that's not necessary. I can just say my data comes first, then my index comes second, and if I rerun these, it's the same thing. So typically, you're not going to be so explicit as far as the arguments are concerned, as long as you pass them in the correct order. I'm just doing it so it's very clear what the data is and what the index is. Okay, so that's one way of creating a series, essentially defining an index or defining data. And we saw that at a minimum, all we need to define is the data. And Pandas will, on its own, create that default index of 0, 1, 2, all the way to however many entries you have. We can also create a series from a dictionary. So let's go ahead and create a dictionary. We'll say ages is equal to, and what I'm going to do here is just create a couple names, such as Sam. Let's say Sam is 5 years old. We'll say Frank. Say Frank is 10 years old. And we'll say, say these are the ages of dogs or something. We'll say Spike is 7 years old. And what's interesting here is what I can do is if I have a dictionary like this, I can easily pass it into Pandas series and say this is just my data. And Pandas is smart enough to make these dictionary keys the index and make the values the array data. So if I run pandas.series, what it's going to do is it's going to automatically transform this into a series. And that's really useful because as we learn about more libraries within Python, a lot of times they return the information in the form of a dictionary. So it really helps to easily organize that information, just passing it into a Pandas series object. All right, so we'll conclude this lecture on the very basics of series, and in the next lecture, we'll continue on by showing you various operations you can perform with a Pandas series object. The main thing you should have gotten out of this lecture is that a Pandas series will go ahead and take in data, and if you want, it'll go ahead and take in a labeled index. And if you pass in a dictionary, it will automatically transform that into a labeled index with corresponding values. Let's go ahead and continue on in the next lecture where we're going to be discussing just various operations you can perform with Pandas series objects. I'll see you there.